Imagine a planet completely covered in lava, under a suffocating sky, wrapped in toxic gases and violent electrical storms. Now imagine that this same hellish world would transform, billions of years later, into a blue planet filled with deep oceans. How did this happen? Where did all this water come from? If the Earth was born as a sphere of incandescent rock, hot enough to vaporize any liquid molecule, how did it end up covered by seas that sustain life? This is one of the most fascinating questions in planetary science. Understanding the origin of water on Earth is understanding the very origin of life. And the answers involve not only our planet, but also cosmic collisions, icy asteroids, and deep chemical processes that began during the formation of the solar system. About 4.6 billion years ago, a gigantic cloud of gas and dust began to collapse under its own gravity. In the center, the sun was born. Around, a disk of material was spinning rapidly, forming grains, rocks, and eventually, planets. In this turbulent environment, the regions had very distinct temperatures. Near the sun, the heat was extreme, making the presence of ice impossible. Further away, the cold allowed water molecules to freeze and incorporate into rocky bodies. This temperature difference is fundamental for understanding modern theories about the origin of Earth's water. If the Earth formed in a warm region, most of the water could not have condensed there. During its first millions of years, the Earth was not a stable planet. It was constantly bombarded by rocky fragments and bodies the size of mountains. Each impact released extreme energy. Many scientists believe that this period, known as the Late Heavy Bombardment, played an essential role in delivering water to the planet. Asteroids may have brought water in their chemical structures. The so-called carbonaceous asteroids are rich in water bound to minerals and organic compounds. Analyses of meteorites show hydrogen proportions very similar to those of the oceans. This strengthens the hypothesis that a large part of Earth's water came from these primitive bodies. This isotopic correspondence is one of the strongest pieces of evidence we have. This suggests that the Earth may have received its water not just from a single event, but from thousands of impacts over millions of years. For a long time, it was believed that comets were the main responsible for Earth's water. After all, they are known as large balls of ice and dust. However, more recent measurements indicate that the composition of the water in many comets does not exactly match that of Earth's oceans. They may have contributed less than previously thought. There is another theory. Water may have been present in the Earth itself from the beginning, trapped in mantle minerals. As volcanism was intense, gases were released. Among them, water vapor. This process is known as degasification. Over millions of years, the atmosphere accumulated large amounts of vapor, which eventually condensed when the surface cooled. When the surface temperature finally fell below the boiling point, the steam began to condense. Intense rains may have fallen for thousands of years on the still hot planet. This moment marks a radical transformation. The presence of liquid water allowed for complex chemical reactions that would later enable the emergence of life. The first oceans were stable environments. Mars and Venus also had water at some point. So why did Earth maintain stable oceans? Factors such as planetary mass, magnetic field, and distance from the sun played crucial roles. The gravity of the Earth was sufficient to retain a dense atmosphere, while its magnetic field protected water molecules from erosion by solar wind. That is why we are the blue planet. The most accepted answer today points to a hybrid scenario: asteroids and internal release from the mantle. But this story is not over yet. Every time you look at the sea, you are observing the result of billions of years of cosmic and geological processes. That vast blue is not just scenery. It is evidence. It is chemistry frozen in time. It is a record of violent collisions, deep reactions within the planet, and radical atmospheric transformations. Understanding water is deciphering the history of the Earth itself. Scientists analyze something called the deuterium-hydrogen ratio. This ratio acts like a fingerprint of water. When compared between oceans and carbonaceous meteorites, it reveals impressive similarities. This strongly supports the asteroid delivery hypothesis. Experiments show that minerals from the deep mantle can store large amounts of hydrogen. Under extreme pressures, water can exist incorporated into the crystalline structure of rocks. This suggests that the Earth's interior may contain volumes equivalent to several oceans. At the beginning of Earth's history, volcanism was much more intense than it is today. Enormous plumes continuously released gases. Water vapor could have dominated the primitive atmosphere, creating a cycle that culminated in the formation of the oceans. The current scientific consensus points to a combined model. Part of the water came from outside, part from inside. This convergence better explains the available isotopic and geological data. The impact that formed the moon may have also influenced water retention. Although it vaporized part of the surface material, the resulting gravity helped stabilize the Earth's axis and its climate over time. Without this stability, liquid water might not have persisted for billions of years. The orbital balance was essential to maintain suitable temperatures. In studying icy moons like Europa and Enceladus, scientists seek parallels. If water can arise and remain in different contexts, perhaps life is not exclusive to Earth. The water of the Earth is a cosmic inheritance, the result of stellar collisions, deep mineral chemistry, and delicate orbital balance. Each drop carries the signature of events that occurred even before the emergence of life. And if these same processes occurred in other planetary systems, perhaps the universe is filled with blue worlds waiting to be discovered. If you want to explore more cosmic mysteries like this, follow us.